So we have Fred Watson with Good Morning Starshine. Thank you, Fred.
Thank you very much. Thanks, everybody. I'm sorry we're a bit squashed in here, but, well, I'll leave you to work out how you're going to make yourselves comfortable. You'll be asleep by the end of this anyway. My job is to squash the entire history of Siding Spring Observatory, 50 years, into half an hour, actually 25 minutes. That means I've got to go very quickly through this talk, but let me explain why it's called Good Morning Starshine. I'm sure some of you remember these. This is the center of a vinyl disc. We used to play them on things called record players or gramophones. And the reason why I'm showing this is that this was published in 1969. 1969 is halfway between the foundation of the observatory in 1964 and the birthday of this telescope in 1974. So I chose 1969, and this record's called Good Morning Starshine, which Amanda and I were going to sing last night, except we simply couldn't get our heads around it. If you remember it, it's got some very strange words in it. So this is not Bob Crow presenting that, it's me. Good Morning Starshine, but really the title of the talk is All You Ever Wanted to Know About Siding Spring Observatory between the origin in 1964 and 2014, where we are now. So let me take you on an aerial, let me first of all give you an overview of what this talk's about. And I should apologize that we've got a picture that's bigger than the screen. That's just logistics which we haven't quite got our heads around, but never mind about that. So this is, as all my talks are, a trilogy in 4 parts. And I want to talk a little bit about the origins of the observatory. I'll say something about what I think was a golden age, particularly of this building, the Anglo-Australian Telescope. I'd like to give you a review of Siding Spring today and perhaps hint at a new golden age that's coming up. And you must forgive me, particularly if you're associated with the Australian National University, that you must forgive me that this talk is rather heavily biased towards the Australian Astronomical Observatory, which is, after all, is the organisation that still pays my salary. So here we are, Siding Spring Observatory. That's the building that you're in now. I've been working in this building for so many years that I've started to look like it, and that's why it feels very homely to me. It doesn't always look like that. On the 13th of January last year, it looked like this. We very nearly lost it. Any members of the Rural Fire Service who are in the room, thank you again. Thank you for all the water bombing that kept our telescopes intact. We lost the lodge, but if anybody had said, which building would you like to lose, that would have been one we'd have suggested. This amazing picture appeared on the front page of the Sydney Morning Herald when the Sydney Morning Herald was big enough to have pictures like this on the front page. It isn't anymore. It shows the dramatic effect of this fire. But today it looks more or less like that. However, 50 years ago, it looked quite different. That's the same view taken in 1964. And there are 2 telescopes on the summit of the mountain. And a closer view shows them nearer at hand. This is the 40-inch telescope. The telescope itself is no longer there, although the dome and the building still exist. And this one is called the 16-inch. The 2 telescopes that were first built here by the Australian National University, opening in 1964. Many other telescopes appeared at the summit of the mountain. I'm sure you will see them, or you have seen them already. It nearly wasn't Siding Spring, actually, because the then director of Mount Stromlo Observatory, a very distinguished man called Professor Bart Bock, was looking at various sites around the country to replace the aging Mount Stromlo Observatory in Canberra, which was suffering from the effects of light pollution from Canberra, as well as fairly indifferent weather. And one of the sites they tested was this one. This is a place This is a place called Mount Searle, which is in the Flinders Ranges. And Mount Searle was as good as Siding Spring, but the reason why Siding Spring got the deal and got the ANU's new outstation was because of the neighbouring town of Coonabarabran. Coonabarabran provides a source of infrastructure. It's a nice town to live in, so you can put engineers and scientists there who will, of course, enjoy the facilities, whereas Mount Searle was much more isolated. Meanwhile, on the other side of the world, at about the same time, July 1967, this was happening. What was happening here? Well, not a lot, because half of them couldn't see what they were looking at, and there's a guy in the background. You might not be able to see him, but he clearly needs a light. What was happening here was a test of casting a large piece of, not glass, but a glass ceramic material called cervit, which has what we call a zero expansion coefficient. It means that as the temperature changes, the mirror doesn't change its shape. That's the bottom line. This was a test casting for the mirror, which now sits upstairs in the dome of the Anglo-Australian Telescope. And a little bit later on, it says, while in May 1969 up there, this is the mirror itself, in blank form. It had just been cast in May 1969, the year of Good Morning Starshine, with some very eminent people. I won't name them all, except this gentleman who was my first boss, David Brown, a man of whom I was very fond because he was one of the leading optical scientists in the United Kingdom at a company in Newcastle on Tyne. Sadly, David died in 1987. But this is what the mirror looked like before David and his team in Newcastle on Tyne put that exquisite surface on it, which is the most precious thing we have in this building. The surface of the mirror is so accurate that if the mirror was, instead of being 4 meters in diameter or 3.9 meters in diameter, if it was the size of New South Wales, the biggest error on the surface would be the size of a pencil laid on its side. It's so accurate, very high accuracy. And you might, from where you're sitting, notice this lovely symbiosis between the mirror blank itself and that big tank behind you, because every year we put the mirror in that tank to replace the coating of aluminium that is on the surface. That was the start of the Anglo-Australian Telescope as I said, in 1969 when the work was beginning. Here at Siding Spring, a whole lot of form work and concrete pouring and building work and scaffolding and lots of stuff was happening to make the building that you're standing in now. I haven't time to dwell on these, I'm just going to whip through them, but look at the scaffolding to put the dome together. Extraordinary stuff. And eventually the dome was completed and the internal work began. There were large pieces of the telescope were delivered. That's the door that you came in a few minutes ago. I beg your pardon, it's not the door you came in, it's the one on the front of the building. There's the mirror arriving on its low loader. A really nice story because the mirror in its protective tank, 3.9 meter piece of very delicate glass ceramic, that started its journey in Newcastle on Tyne in England, finished its journey by sea in Newcastle, New South Wales, and then was transported from Newcastle to Coonabarabran on this low loader. When it got to the town of Coonabarabran itself, there was a formal welcome reception for the mirror, because everybody in town realized what a big change this was going to bring to the little town of Coonabarabran. And indeed, the mirror had a lap of honor through the town, which was so popular that they did it twice. It went round town twice before it got up the mountain. They assembled all these large chunks of stuff, and what eventually came about was the telescope that I'm sure many of you have already been upstairs to have a look at. The biggest visible light telescope in Australia. The 3.9 meter mirror sits down in the bottom of it here now. Where do you look through on a telescope like that? Well, sadly you don't. You don't look anywhere. You sit in a control room and look at screens. And you can do that. We did that back in the early 1970s. I put this photograph in because I cannot resist it. This is Rob Dean, who is one of our heroes here at the AAO. He still works for us. Nowadays, he looks like that. The ravages of time. At least he's still got some hair. Rob is actually the longest serving member of our staff. I have the privilege of being the oldest member of the staff, but I'm not the longest serving. Rob is a very valuable part of the Australian Astronomical Observatory's retinue of highly trained staff. And you can see the kind of thing that you have to look at when you're working with the telescope and using it. If you go out on the walkway, I'm not sure whether the walkway is open today. It is good, okay. Well, from certain angles, you get to see some of the other telescopes on the mountain, including this little cluster over to the northeast. And this building here, the one on the left, is the building of the United Kingdom Schmidt Telescope, sometimes referred to rather unkindly as the Schmidt House. But the Schmidt Telescope is very close to my heart because that's what brought me to Australia back in 1982. And the Schmidt had a similar ancestry. So it was built as the AAT was being built. There's the AAT dome going up in the background. Work started, I think, in 71, and all the usual sorts of things when you build a building like this, putting the dome on, much smaller building, of course, but I love this picture of the telescope being hauled into the dome through the opening. Unfortunately, you can't see that telescope today because we're completely refurbishing it. It's about to have a new lease of life, which I'll tell you about in a few minutes, and that's why we haven't got it open to the public. But it looks like that. This is a photograph taken a few years ago. In fact, this little enclosure which held something called the 60F robot, which I haven't really time to tell you about, but that enclosure is now gone and the dome is being totally refurbished. In fact, the last time I put my head in the dome, it was full of scaffolding, a bit like the pictures that you saw a minute ago. So, in terms of the origins, let's just get the details there. Really the biggest event in the observatory's history was the signing of the Anglo-Australian Agreement, which essentially committed the Brits and the Australians to funding half of this building each and running the telescope half-time. They the observatory, as you'll hear in a minute, is now operated entirely by Australian government funding, but originally it was a joint thing. First light, the first test photo, April 1974, 16th of October 1974, our 40th birthday, Prince Charles came and said, "I declare this aperture open." That was what he did to formally open the telescope. We actually have some video of that. I don't know whether it's on display anywhere, but it is quite entertaining. He makes a very nice speech, but he ends with declaring the aperture open. And then the fully commissioned telescope entered service in June 1975. However, as I said earlier, the Brits had decided to build a survey telescope, a telescope that would take wide-angle photographs of the sky to show the most interesting bits of the sky for the big telescope to look at, and that was the UK Schmidt. That was opened on the 17th of August 1973 and entered service very shortly after that, operated as it was by the Royal Observatory in Edinburgh. And that's where I was working when somebody said, "Why don't you go to Australia for 3 years and work on the Schmidt telescope?" That was in 1982. So what do I mean by a golden age? Well, there was a period early in the AAT's history when it really did make history because it was the first computer-controlled large telescope, which meant that it could be used very easily and very readily by the world's astronomers. But we also had the advantage of the fact that the telescope was used for, as I've said there, you can't read it, but iconic imagery. And there is a gentleman who is somewhere in the audience and is going to talk to you later. Sometimes he looks like this. You will have to ask him why he was wearing 2 oven gloves on his head when I took this picture. His name is David Malin, and David basically is the person who pretty single-handedly invented color photography for the sky. And by that I mean not just sticking color film into a telescope, but developing a 3-color process that allowed us to see what the sky would truly look like if our eyes were 1,000,000 times more sensitive. This particular picture is of the Pleiades star cluster. It was actually taken on the UK Schmidt telescope, but it shows very nicely the symbiosis that existed in the 1970s and 1980s between the Schmidt, operated from Edinburgh, and the AAT, operated from here in Australia. So David firmly put things on the map. His pictures appeared on record covers, book jackets, magazines, all over the world, and of course all had a credit for the Anglo-Australian Telescope. And we were helped too by a bit of good fortune. I won't explain what this picture's about, David himself might do that, but it shows a star that exploded in 1987, supernova 1987A, which is actually the black dot at the middle there, and that was an event that actually again propelled this telescope into the forefront of world astronomy, because we were in the ringside seat to observe this once in many lifetime events. The last naked eye supernova, the last exploding star that could be seen with the unaided eye, occurred 400 years before this. So 1987A was a very important thing. And I've said, I think at the bottom, helped by a little serendipity or something like that, because that certainly helped too. So for the imaging that we used on the Anglo-Australian Telescope, in the early days it was photography, but then electronic imaging came along. David used photography for many years, but of course is now fully electronic, as you'll hear. But this is just a potted history. I haven't really time to tell you about the details of the way the telescope was used to form images of the sky, magnified pictures of what we could see deep in the sky, very faint light. But it turns out that, for reasons that you can come and ask me about later if you want, we are better placed here to do something called spectroscopy. And spectroscopy is the science of breaking up the light from stars or galaxies into their component rainbow colors to make a spectrum. And when you do that, you reveal this barcode of information that has huge amounts of detail about a star's makeup, what it's made of, what its speed is, what its temperature is, what its gravity is. All these things come from the spectrum of a star. And so spectroscopy, the science of the spectra of the stars, became very much the AAT's stock in trade. And in particular, in 1981, a scientist here called Peter Gray began the first experiments with optical fibers, and that is now something that we use very extensively. I'll explain it in a little bit of detail in a moment. So a whole variety of interesting instruments there. Similar things were happening at the Schmidt telescope as well, because the photography of the Schmidt telescope was really what occupied the telescope for the first 2 decades or so of its existence. And then in 1982, this nutty astronomer came from Edinburgh by the name of Fred Watson, wanting to put fiber optics on the Schmidt telescope, and we had a succession of instruments with fancy names: Flare, Panache, Flare 2. Flare stands for Fiber-Linked Array Imagery Formatter, and Panache was panoramic area coverage with higher efficiency. And actually the third version, which we built in 1982, I wanted to call Finesse, to carry on the... But somebody said, well, Finesse should stand for fails to interest nearly everyone, save spectrograph engineers, so we didn't call it that. We called it Flare 2 instead. Lots of stuff from Comet Halley. Our last photograph was taken actually in 2005, although we really stopped photography in 2001. That's what a Schmidt plate looks like. They were 14 inches square, 356 millimeters, a millimeter thick, and they were negative, so everything bright in the sky looks dark on the negative, but they were rather fragile. And in fact, many of them were sat on inadvertently. We now do just fiber optic work at the Schmidt telescope. So what's Siding Spring like today? Well, that's the beautiful portrait of the AAT dome getting ready for a night's work, with actually the no longer existing lodge in the foreground, which you can't really see in this picture. Of course, I've neglected the ANU's activities, and that's shameful. ANU is the owner of the site. We are their tenants, the AAO. But the ANU, of course, have big telescopes as well. In 1984, this instrument, the 2.3 meter telescope, which has a mirror 2.3 meters in diameter, a very sizable instrument, the second largest astronomical telescope in Australia, in a building that rotates. That was opened by a fellow called Bob Hawke. That has basically been used for some of the most high precision measurements, spectroscopic measurements of stars and galaxies. The retinue was joined in 2004, so this is a 10th anniversary, by this curious looking instrument which is called the Fawkes Telescope South. You can go and see it and they'll tell you all about its history because it's open to the public today. The Fawkes Telescope is now operated by an organisation called Las Cumbres Global something Observatory, and they have other telescopes as well, like these two 1-meter class telescopes, which are in the foreground there. So the Fawkes telescope, go and have a look at it, an amazing piece of equipment. And the most recent telescope to be completed on the mountain, again by the ANU, although there are other smaller instruments being completed, in particular one bigger than this actually, being built by the Koreans. That's very nearly finished. This is the Sky Mapper, the ANU's flagship instrument with a very wide field of view, something like 6 degrees, and I think it's something like a 270 megapixel camera on it. So forget about your 4 or 5 megapixel cameras. This is big news, and that means it delivers gigabytes of data, and of course there are all kinds of issues concerned with that. It's looking at the sky in many different colors to identify things like supernova explosions. That's actually why it was built, but it also will reveal anything that's moving in the neighborhood of the solar system. So it'll be a good way of finding near-Earth asteroids. I can't resist showing you, and forgive me Andy, because I think you took this picture, this stunning portrait of Sky Mapper in a thunderstorm. Is this yours? Yeah, Andy Green, who's on the camera there, took this marvelous photograph of Sky Mapper, just missing the lightning. Siding Spring Mountain is one of the most lightning-struck places in Australia. Great place to build an observatory, but actually it works very well. Let me just go back now, because we're talking about Siding Spring today. Thank you very much, Kyla. Let me go back to this thing about fiber optics, what we call multi-fiber spectroscopy. What's it all about? Well, if you imagine a telescope like this one upstairs, what it does is makes an image of the sky. It basically delivers an image. And if you want to, you can put a photographic plate there or an electronic detector and take a picture of what you're looking at. And that's what we call scientific imaging. But what we do with the fibers is, instead of taking an image, we use optical fibers, which you can think of as light pipes. They're a bit like guitar strings, except if you put light in at one end, it comes out almost undiminished at the other. And those light pipes, what you can do is align each one of them, many of them, on each target that you're interested in the field of view of the telescope. So you can basically suck light from galaxies, as I've shown here, and bring them all to a different place, feed them into a thing we call a spectrograph, which means that you get a spectrum of each of these objects simultaneously. You don't just get them one at a time, which is what we had to do beforehand. And of course that gives you the answer, nearly the answer to life, the universe and everything, because it lets you do measurements of objects hundreds of thousands at a time. And that is the process that's really been pioneered here in Australia. This was the first system that was used on the Anglo-Australian Telescope. So the image of the sky is formed here, and these fibers, these were actually plugged into holes drilled in a brass plate. That was the way we used to do it in the early 1980s. You might see my name up there because this was one of my observations made in 1983. Nowadays, we have very much more advanced systems. As I said, if you were there at Science in the Pub last night, we thought we could do anything in those days, but we didn't realize it would be quite expensive and would cost millions of dollars. This is a thing called 2DF on this telescope. It's a robotic fiber positioner that uses a robot to move the fibers around. So rather than drilling holes in brass plates, you move the fibers with a robot, and the fibers have to be positioned to about 1/100 of a millimeter. So they suck the light from these stars or galaxies or whatever you're looking at. That was the first big job that the 2DF instrument, as it's called, 2DF stands for 2-degree field. It's a terrible name. But what it did was looked at the positions of about 250,000 galaxies, making this three-dimensional map of the local universe. The reason why it's shaped like a butterfly is that this region, our galaxy is a tiny, tiny dot in the middle, but because of the alignment of the Milky Way, the disk of our galaxy, you can only see to the north or to the south of that. Great stuff and fantastic research. This is the latest incarnation of 2DF. We now have an instrument which is called Hermes. It was commissioned at the end of last year. It sits in a room not far above our heads. It's a giant instrument. This is 3 of our engineers who were working on that. And we are doing a survey of 1 million stars called Galar. galactic archaeology with Hermes. Who thinks of these names? That's what it stands for. Galactic archaeology is looking at the origin of our galaxy. As I've said there, flying through the Milky Way with Galar. The Milky Way is basically this giant system of about 400 billion stars. And we think it looks like this. We can't photograph it because we're embedded in it. The sun's position is here. It's got these beautiful spiral arms. But what we know is that galaxies grow by gobbling up other baby galaxies. And this is a distant galaxy on its edge that we can see actually in the process of swallowing up the stars of another galaxy. So galactic archaeology is all about trying to learn about how galaxies have originated and how they've grown. A new golden age. Well, I'm now talking about the AAO, the ANU. I think is very much part and parcel of this, and in fact plays a very important role in it. But what is happening now is that the Anglo-Australian agreement has disappeared. That came to an end in 2010, and the observatory became something operated solely by the Australian government, a division, in fact, as we are now, of the Department of Industry. There's no science department within the federal government. But the key thing that I wanted to mention is that our remit now extends beyond the AAT and the Schmidt to other facilities throughout the world in which Australia has involvement, and one of them is the next big thing. It's this gigantic telescope called the Giant Magellan Telescope. It will have 7 8.4 meter diameter mirrors. There's a human figure on the same scale. It will be built in Chile, but it will have Australian involvement. Those mirrors are much bigger than ours. That's one of the blanks that's been already cast in Arizona. Look at the size of it, 8.4 meters in diameter. But we are playing a role, and our Schmidt telescope, which is shown in this picture, is a very important part of that, because we are building a fiber positioning instrument which will actually allow us to use optical fibers in a completely new way. They're called starbugs. Our engineers down in Sydney have invented these things which position the fibers autonomously, and we're building a system called Taipan, which uses these little robots. They're the fibers moving about on their own. They don't have to be picked up and put down. And that revolutionizes the way that we can do this kind of science. It'll be used on the Schmidt telescope for 2 new surveys, but this will be a prototype for a big new instrument which will eventually find its way to the Giant Magellan Telescope, and you will all hear about it, and I hope we'll all be proud of it. That is the end of my Good Morning Starshine survey, but thank you very much for your attention, and if you've got any questions, I'll be very happy to answer them. Thank you.